Hello guys, my name is Connor and I'm here with UConn HKN doing a quick robotics problem on inverse kinematics. The entire idea behind inverse kinematics is that we are given the coordinates of our end effector, which is this point here, and we have to calculate or find an equation for the inputs of our various robotic arms or rotators. And what these blocks mean, this cylinder is a revolute joint, so it rotates an angle of theta. That's an input. These prismatic joints move up a distance of d2 in this direction, and in this direction, d3. So in order to find these equations, it's quite simple, but it's quite difficult to draw out the correct coordinate frames and look at it from the right view, so I'm going to try and go through that. To start off, I have these coordinate frames drawn out, but I don't have anything labeled. So an easy way to start out is by starting at your base joint, which is right here. This is grounded. This isn't going to move. We can usually just use the base frame as we normally would, where it's kind of easy to think that going up in space would be z. So this one would be z, 0, because this is our 0 frame. Our next point would be x0, and this one we can call as y0. Doesn't matter as long as you're consistent from here on out. Here, since this prismatic joint just goes up, we're going to use the same frame, y0, but not 0. There'll be the same x, but since this is a new coordinate frame, we'll call them x1, y1, and z1. If my handwriting could be a little bit better, but that's the idea behind that. And then this frame is going to be a little bit different. They're going to be x1, z1, or x2, y2, and z2, but we have to think of it as if it was flipped. This one was flipped on its side. So if this one was flipped on its side, the z direction goes out of the box, and the x direction goes down, and the y direction still goes out. So we can call this as z2, this one as x2, and this one as y2. And same idea here, we're not doing any rotations, or it's just along the same line. So this endpoint can be called z3, x3, and y3. So in this problem, we're given z3, x3, and y3, and we want to calculate d2, d3, and theta, the inverse problem. So in order to do that, we can't really do it by looking at it in this frame. We have to look at it in different ways. The easiest way to do that is to look at a side view. So looking at it, draw an eyeball. We're looking at it right. So if I drew some eyes, if it was on the screen, we are looking at it dead on. So dead on. And we're going to do another frame where we do a top down. So side view. And then a top view. So we'll start with the side view. So we have to redraw this while looking at it head on and ignoring all other coordinates or variables that wouldn't really make sense in there. So in this frame, for example, we're not going to be looking at the rotation because we're looking at it head on. So if I did a side view right here, quickly try and draw this out. So the side view being, if we can see, this is the cylinder. Just draw it as a square. Looking at it head on, then we don't worry about y naught because we're only looking at it in 2D. So we get rid of y naught and we look at it x naught and z naught. And another thing I didn't forget to mention, was this distance is a fixed 1 because this This revolute joint only rotates. It does not go up or down, so the distance between here and here is 1. Same with this joint, 1 and 1. So we go up to the second one, being 1. Same idea. We get rid of the y, x1, z1. Have this nice little corner. Now, same idea here. We're also going to be getting rid of the y because when we flip this over, we're still looking at the side view, and the y coordinate is still the one coming out of the page, so we ignore that one. So this is still the same idea, z2. And going down is x2. And then out here is our end effector, z3, x3. Okay, now what does all this mean? If we redraw our variables that we have a better look at how we can calculate things. Now this view only gives us one of the variables we need, but it'll still work out. So on this one, the only variable that we can calculate using this is distance, because we don't have the angle. So using this point z3, we want to be able to calculate either d3, d2, or theta. We don't have theta, and let's try to calculate d2. So this would be d2. So looking at here, if we knew the point z3, then we would know that z3 is just in the frame of z3 according to 0. It's if this is the 0 point, it's how high up in the z-axis is this point. So that's directly related to 1 plus d2, because the z-coordinate is how high you are. So we can say that z3, 0 is equal to d2 plus 1. Now, if we want to solve for d2, that's simply d2 is equal to, if I can do simple subtraction, z3, 0 minus 1. So we already have d2. We can't really calculate x3 from here, so we're going to need to look at the top view in order to do that. So the top view is a little bit trickier to look at, because when we look from the top, we're going to see this. We're going to see two joints on the same joint, or two joints on the same little square. But we're going to have to draw both of them. So we'll start just by drawing the cylindrical joint right here as a circle, and we're going to want to encapsulate theta because we need an equation for that. So we can kind of think of this this prismatic joint rotating slightly. So we can draw the square prismatic joint rotated. And what this means is that if looking down on it, we're not going to have a z component. We're only going to be looking at the y's and the x's. So looking down in the cylindrical frame, this would be y0 coming out from here, x0. Then normally those are in parallel if there is no rotation, but if this was rotated, you could see that y1 and x1 would rotate a certain amount. So that's what we're going to do here. And that y1 is now going this way, and x1 is going this way at an angle of theta. This prismatic joint is rotated by an angle of theta. And we can see that in the whatever way this is rotated, that's the direction x1 is going to be the direction that this joint is connected from. So we can then draw our third joint, the right here. Now, same idea, we're looking down on it, so we're not going to have an x component. We're only going to be looking at the y and the z, because the x is also going down, so we're not worried about that. So the z will go out the same direction that we came in, and the y goes down. This is 3. All right, so how do we get an equation out of here? Trig, beautiful triangles. So let's draw a nice triangle here. Use a different color. So if you remember, we're given z3 and x3. So z3 and y3. And right now, if I can remember correctly, this right here, because this is the x direction, this is x, this distance is x3 with respect to the frame 0, with respect to here. This is x3, because you can see that this that we labeled here was x0. And this going up, if I had labeled it correctly, this would be more angled down. So this would be actually y3. So now, what is this distance here? We have theta, and you can kind of see I'm going for the Pythagorean theorem. So we need from here to here. So if we look back on this this equation, that's what here to here is we look down and we're seeing the distance along here. So that's 1 plus d3. So this whole different distance is 1 plus d3. So using trig, we're going to be able to solve for d3, which Pythagorean theorem, we're going to have x3 0 plus y3 0 x squared, or yeah, is equal to 1 plus d3 squared. Solving for d3, we're going to end up with d3 is equal to it all squared, square root, minus 1. Now we have one last variable to solve for. We found d2, d3, now we need theta. The easiest way to do that is using the tangent, because since we're given y and x, we can do the tangent of theta is equal to opposite over adjacent, y3 over x3. So the theta is equal to tan inverse of y3 over x3. So now we have our 3 equations that relate our inputs, theta, d2, d3, to our given end effector coordinates, z3, y3, and x3. Thank you very much. If you have any questions, please respond in YouTube comments. Please subscribe, and we'll talk to you soon.